All right, this is a tough question. So we have a voltaic cell that is at non-standard conditions. We don't know what those conditions are, and so we're trying to find what the ratio is of iron to cadmium to get a voltage of 0. Now our E naught is 0.04 volts. So we have our equation. So okay, so we're gonna have to solve for the ratio of Q. So let's get Q on its own side to start out. So we have 0.0 volts equals 0.04 volts minus 592. Let's figure out what the N is. So we have 2 plus going to 0. So we have there's 2 electrons. On the other side, we have iron. So it's 2 electrons for both. So that's over 2. So first thing I'm going to do is subtract the 0.04 from both sides. So I have 0 minus 0.04. And that equals a negative 0.0592 over 2 times log of Q. So let's get that negative. The 0.0592 divided by 2 is 0.0296. I'm going to divide both sides. So negative 0.04 divided by 0.0296 volts. And I get 1.35. Okay, so 1.35 equals log of Q. So if I take both of those to the 10, I get Q, the ratio. So 10 to the 1.35 equals 22.4 Q. And that's the ratio. Remember, Q is based on our equation, which is up here. The solids do not get counted. So we have only Fe 2 plus over CD 2 plus, nothing squared or cubed because we don't have any coefficients out front. So what is that iron? So what we're trying to solve for is what Q is equal to. We don't know the exact ratio. It could be 22.4 to 1, or it could be 44.8 to 2. It could be 0.0448 to 0.002. But we know that Q, the ratio is 22.4. If we did know one of the concentrations, we could solve for the missing one. But in this case, we don't know either. So we're just solving for the ratio. There we go.